So biochar is just one term that describes a wide range of different products. It's not a silver bullet, it's not a pill that is going to cure all sicknesses. Rather, it's a very diverse product that can be part of an integrated climate combat strategy. I came to this conference to talk about biochar, of course, and more specific, the co-production of energy and char, and how we can co-produce actually energy and char to the benefit of both. The focus of the presentation was to give an overview of biochar production technologies, because this is actually what we are doing, finding the best, or the optimum technology and processes for producing a high quality material that we call biochar, and also try to link our activities with other very important players like agriculture research and soil engineers. What we have seen is that lack of good communication between technology developers and biochar users. So we still speak a different language, and in order to really bring innovation in agriculture and climate change, all the players have to sit on the same table and try to understand each other. We cannot develop a very good product, a good biochar, if we don't know the exact need and the exact criteria that we have to keep. An interesting concept that we have been working on the last years is the co-production of energy and char, what we call Enerchar. It's a further development of an established gasification technology at TNO, former ECN, with the goal of co-producing good quality syngas that can replace natural gas, and to a smaller extent the co-product biochar that can replace substrate components like peat or perlite or other not so sustainable components in agriculture. We have done some life cycle analysis and in more specific greenhouse emission study, and we came to the conclusion that we can achieve considerable negative emissions, so we can achieve actually carbon capture and storage by combining proper feedstock, the Enerchar, energy and char technology, and also replacing this char in horticultural substrates. So we can eliminate more non-sustainable elements like natural gas and peat, and achieve not only neutral but also negative emissions. In those last 6-7 years that we have been researching biochar, we have produced a lot of different biochar types that originate from different feedstocks, from relatively clean wood down to really wet digestate. They all go into a thermal process called pyrolysis, and the end product, the biochar, can be used in different applications according to its particular properties. So a highly porous, nutrient deficient biochar is a very good candidate for peat replacement in substrates, in horticulture and intensive agriculture, so in greenhouses, where the potting soil industry wants to compose their own substrates and adapt, add or complement with nutrients, while the highly nutrient feedstocks give chars that are still loaded with quite some nutrients. They can be applied directly in the soil as slow release fertilizers. And another very interesting area that is under development is use of char in environmental applications, like filters for water, for air, in energy storage, like in battery, and also in the steel industry, where the biochar can actually replace coal.